Hi, Assalamualaikum and good day. Today you are going to learn about determinant. In linear algebra, determinant of a matrix is referred to a real number that can be calculated from a square matrix. Determinant is useful in finding the solution of system of linear equations. Determinant of matrix A is denoted by DETA or modulus A. Determinant is only defined for a square matrix. The determinant of 1 by 1 matrix is referred to the number itself. A 1 by 1 matrix is also known as a square matrix of order 1. For example, let's say given a matrix with -2 as the only element inside. Therefore, the determinant of this matrix is equal to that element, which is equal to -2. For a square matrix of order 2, the determinant of this matrix is equal to the product of the elements on the main diagonal minus the product of the element of the main diagonal. That is, A11 multiplied with A22 minus A12 multiplied with A21. For example, given a square matrix of order 2 as follows. The determinant of this matrix is obtained by cross-multiply the element and subtract. That is, 2 times 5 minus with 4 times -3 equal to 22. Let's do example 7. Given square matrices of order 2, find the determinant of each matrix. For the first square matrix, the determinant is equal to 2 times 5 minus 4 times -3, which is equal to 22. For the second square matrix, the determinant is equal to -3 times 2 minus 0 times -1, which is equal to -6. As for the last square matrix, the determinant is equal to x times 1 minus y times 0, which is equal to x. Bear in mind that we are using straight lines for the determinant and the answer must be a value. Do not mix up with the bracket used for matrix and determinant. If you use the wrong bracket, marks can be deducted. For a square matrix of order 3, there are two methods that can be used. For the first method, rewrite the first two columns on the right side. Then, take the sum of the product of the first three top left bottom right diagonal and minus with the sum of the product of the first three top right to bottom left diagonal. For example, consider the following square matrix of order 3. The determinant of this matrix is equal to A11 times A22 times A33 plus A12 times A23 times A31 plus A13 times A21 times A32, then minus with A12 times A21 times A33 plus A11 times A23 times A32 plus A13 times A22 times A31. Simplify this, you should get a value as the answer. Let's do example 8. To find the determinant of the given square matrix of order 3, first rewrite the first two columns on the right side. The determinant is equal to the sum of the product of the first three top left bottom right diagonal minus with the sum of the product of the first three top right to bottom left diagonal. That is 2 times 1 times -3 plus -2 times 0 times 0 plus -1 times 1 times 4, then minus with 0 times 1 times -1 plus 4 times 0 times 2 plus -3 times 1 times -2. Simplify this, you should get negative 16 as the answer. The second method of evaluating determinant is by breaking down the matrix into smaller 2 by 2 determinant using minor and cofactor. Minor, which is denoted by capital MIJ, is referred to the value of determinant obtained by deleting the ith row and the jth column. Cofactor, which is denoted by capital Cij, is defined as negative 1 to the power of I plus j multiplied with Mij. Negative 1 to the power of even number is equal to 1, and negative 1 to the power of odd number is equal to negative 1. Refer to example 9. Find minor 2, 1 and cofactor 2, 1 for the following matrices A and B. For matrix A, minor 2, 1 is obtained by deleting the second row and the first column. You should get 1 as the answer. Therefore, cofactor 1, 2 is equal to negative 1 to the power of 2 plus 1 multiplied with 1 equal to negative 1. As for matrix B, by deleting the second row and the first column, minor 2, 1 is equal to the determinant of order 2, which is negative 1, 3, 1, 0. By cross-multiply the element and subtract, the answer is equal to negative 3. Therefore, cofactor 1, 2 is equal to negative 1 to the power of 2 plus 1 multiplied with negative 3. The answer is 3. In general, if A is a square matrix of order n, then the determinant of A is defined as A11 cofactor 11 plus A12 cofactor 12 plus A13 cofactor 13 plus so on plus A1n cofactor 1n. Or, by using minor, the answer is A11 minus 11 minus A12 minus 12 plus A13 minus 13 minus so on plus A1n minus 1n. Take note that if you use minor, the sign is alternate from plus, minus, and so on. This is called the Laplace expansion of determinant A along the first row. Determinant can also be defined using any row or any column, but it will be advisable to use the first row to avoid careless mistake. In specific, the above expansion of determinant A is known as cofactor expansion along the first row and minor expansion along the first row. Let's do example 10. Find the determinant for matrix A by using cofactor expansion along the first row. By using cofactor expansion along the first row, determinant of A is defined as A11 cofactor 11 plus A12 cofactor 12 plus A13 cofactor 13. A11, A12, and A13 are the elements in the first row. Cofactor 11 is equal to minus 11, cofactor 12 is equal to negative minus 12, and cofactor 13 is equal to minus 13. Minus 11 is obtained by deleting the first row and the first column. Minus 12 is obtained by deleting the first row and the second column, and minus 13 is obtained by deleting the first row and the third column. Minor is calculated by cross-multiply the elements and subtract. By substituting the corresponding element and minor into the formula and simplify, you should get 13 as the final answer. Proceed with example 11. Given a square matrix of order 3, Find minor 1, 1, minor 1, 2, minor 1, 3, cofactor 1, 1, cofactor 1, 2, and cofactor 1, 3. Hence, find the determinant of the given matrix. M11 is obtained by deleting the first row and the first column. M12 is obtained by deleting the first row and the second column. M13 is obtained by deleting the first row and the third column. Minor is calculated by cross-multiply the element and subtract. Thus, minor 1, 1 is equal to negative 2 times negative 3 minus 3 times 7, which is equal to negative 15. M12 is equal to 2 times negative 3 minus 0 times 7, which is equal to negative 6. And minor 1, 3 is equal to 2 times 3 minus 0 times negative 2, which is equal to 6. Cofactor is obtained by applying the formula negative 1 to the power of I plus j multiplied with minor ij. Thus, cofactor 1, 1 is equal to minor 1, 1, which is equal to negative 15. Cofactor 1, 2 is equal to negative multiplied with negative 6 equal to 6. And cofactor 1, 3 is equal to minor 1, 3, which is equal to 6. Therefore, determinant of A is equal to A11 cofactor 1, 1 plus A12 cofactor 1, 2 plus A13 cofactor 1, 3, which is equal to 1 times negative 15 plus 5 times 6 plus 4 times 6 equal to 39. In order to get better understanding on this lesson, please do exercise 1.4. In the next lesson, you are going to learn about properties of determinants. So,